So in this video, you are going to learn how to identify different function of different component of BMP. Again, the functions that BMP provide is either storage or infiltrations or filtrations of pollutants. And so you can see that as the different components of those functions. So let's see the examples. So overall green infrastructure reduce impervious surface. That's a function provided by every single green infrastructures. And the fact that it store water or reduce the flow rate of water, it can decrease erosion. So this is related to decrease erosion, related to decreasing decreasing peak flow or peak velocity. So that means any time when the stormwater flow is stopped or not stopped, but slow down or hinder or retarded, that's the time you decrease erosions. Increase retention or detention, that's basically related to storage. If you have any layer where the size is big and there is a depth where water can pond, that basically gives you increased retention or retention. Increased infiltrations, that's related to the filter layer. Infiltration means going to the ground. So that means anything related to the soil layers below it, and that basically will give you that increased infiltrations. How do you control it? You control it by changing that media from soil to something else like sand. Removal of pollutants is related to everything that happens there, and we'll look at a different aspect there. So here, for instance, I show you an example of biofilters or bioinfiltration systems. If you want to have BMP components, what kind of pre-treatments you can design. So this is actual bioinfiltration system. So that means pre-treatment has to happen beforehand. So there are example of things you could do here is that you can, when the water comes in here, you can put a lot of stones or some kind of obstacles so that water speed slow down. That will protect the water from there. You can also have plants that can, or filter strips that can basically take a lot of gas out. So these are the pre-treatment things you could do to remove that. Either put a stones to slow down water or put plants to remove that. And then in the BMP, you have plants. These plants provide many functions. The first functions that they provide is makes them looks beautiful. That's one functions. But also they have this root system, and that root system would continue to create a preferential flow path for infiltration to happen for a long time. So these plants can also increase or it basically maintain the help maintain hydraulic conductivity, maintain infiltration capacity. And it also helps remove pollutants because in the root zone you have a lot of microorganisms that can also degrade or enhance the degradation of pollutant. Some pollutant can be directly uptake by plants, but it's a slow process. So it's all it does, it basically removing pollutant from the filter media so that those media can continue to operate for a long time. Without plants, this pollutant will accumulate. With plant, they will be either destroyed or being uptake by the plants. And plant obviously reduce the erosion by slowing down the water. And this retention area over here, basically that's the size. Size provides related to storage. So that means you have more stored treatment volumes. If you have large depth over here, that means there is a lot more water can pond there. High ponding means high gravity flow, and that means water can be pushed through it, and that means it will have more infiltration rate. So just by having more ponded water, it can increase infiltration because of the pressure that water creates. And it basically captures a lot more water volume, so that means reduced flooding. Having the system can remove sediments because of settling as well as the plants. So by this can be happening by settling or plant filtrations. The last component is filter media. Filter media is by far the most important component which allow water to move quickly. So this is usually combination of sandy materials because sand has high hydraulic conductivity. So the goal here is to increase infiltrations and remove pollutants. So this is increase infiltrations and remove pollutants by directly absorbing them. So that's why a lot of times the filter media could be a combination of SAN and biochar, activated carbons, or some kind of reactive media. And because of this media, they can also have create a conditions for microbial community to grow, and so that you can control that to degrade the pollutants. The last one in many locations you can see over here is called storage layer. This is basically a mix of sand or gravel, and most time it's just the gravel. And this storage layer means now as the water treated, it creates a large high hydraulic conductivity locations where water can store so that you can pump it out or you just can drain it more quickly. So that's why you have this large gravel or the layers over here. A lot of times, if you want to increase the storage layer or you want to saturate the storage layer, it can provide other benefit like denitrifications. Because denitrification happens in anoxic conditions. Anoxic conditions require something to be submerged for a long time. That's why what they do is they basically create the raised outlet. If you have the raised outlet like this, so water will be always ponded up to here. And because of that, you'll have more denitrifications. Having another benefit of a raised outlet is that the water, when it's pond over here for a long time, this basically keep the water for infiltration to occur for a long period of time. So having ponded layers helps increase infiltrations and capture. And I mentioned drainage layer. Drainage layer, the only function is to drain water as quickly as possible when needed. So that's basically a lot of gravel here. This is just for draining purpose or reuse.